So we have 7 times negative 4. Then I'm going to put all of my like terms, and I'm going to put all my like variables. I start with t to the 11th. Then I have t to the negative 9. Then I'm going to take a look at my u's, and I have u to the 3rd. And Jack, oh, I forgot a number. I have to have a 2 out here too, right? What's the last u that I have? Negative 5. Did your guys have a parenthesis? I think that's where this is off. So this one doesn't have an exponent here. Did it on yours? No. So that's, I think, the answer in the back might be off, and you could have done this correctly. But do you have it outside of this parenthesis? Ah, 2, yeah. That's where mine doesn't have it. And not this 2, right? Yeah. Okay. So that is my fault. All right, so let's go back. Sorry. It's not this 2, it's to the 2nd power. So the first thing I'm going to do is I'm going to write everything. I have 7, t to the 11, u to the 3. This 2 is telling me that I have to have negative 4 to the 2nd. And here, I'm going to take negative 9 times 2. That gives me negative 18. And then t to the negative 5. If I'm now grouping my numbers, I have 7 times negative 4 squared. I'm going to use my calculator for that, right? So negative 4 times negative 4 is a positive 16. And then I take 16 times 7. So when I get this answer, I'm going to have 112. How did I get that? 7 times 16, okay? Now I'm going to put all my t powers. As I'm looking at my t powers, I have t to the 11th, and I have t to the negative 18. Then I have u to the 3, and I have u to the negative 5. As I look at that one, Abby, when I add 11 and negative 18, I'm going to have t to the negative 7. I'm going to have u to the 3 times u to the negative 5, which means I'm adding those together. Channing, I'm going to get 3 and negative 5, negative 2. So at this point, I might have put 12 all over 1. Okay? If you don't have this and you're not writing it down for me to check, you should make sure you're copying and having this down on your paper. So at this point, I have a positive 112, and I have a negative exponent. To make the negative exponent positive, I move it to the denominator, and it's 7 power. Do you have something to write with, Jack, to fill this in? Okay, make sure you have yours. And then I should have u to the 2nd. And this was the answer that you got. But that power here means you have to take 2 of each thing in there, or multiply the exponent times 2. And usually the most common mistake is that people just get negative 28 for one of them, and then that other negative. Right? See, m to the 2nd raised to the 8th is just going to give me m to the 16. Then I have m to the 0 raised to the 4th, which 0 times 4 is still going to be 0. And anything to the 0 power is 1. So this is m to the 16 times 1. M to the 16. 16. This is kind of bringing together all of our properties, but in particular, we want to look at division. We did some EdPub or some Quizlet Live the other day with these. 4 to the 5th means, and again, if you get stuck on the quiz next week, write out what it means. It means that we have 5/4 divided by 3/4. But again, as we look at this, this is really 4 divided by 4, which is 1, and 4 divided by 4, which is 1, and another 4 divided by 4, and I'm left with 4 to the 2nd. So when I think about that shortcut, the shortcut that we could use is when we divide. So please write dividing powers, divide powers, same base, subtract the exponents. Make sure you're looking at your subtraction as you're doing those. Negative exponents always have to become positive when we take our quiz next week. Top of the next page. The first denominator, when I am looking at that, Zach, m to the 6 over m to what power? 1. So I am simply going to take 6 minus 1, which as I'm looking at that, Jeannie, gives me m to the 5th. I'm done with the problem, right? My answer was m to the 5th. The next one, I'm looking at a d to the 3 over d to the 3. I have the same base. 3 minus 3 gives me 0. So I get d to the 0, which equals 1. Couldn't I have maybe done that right here? D to the 3 over d. They're exactly the same and said, oh, this is the same as 1 over 1. Yes. Okay. We're starting this next one. This is the one that gets people problems. This line actually means division. So the first thing you are doing is actually taking, Jack, 10 divided by 5, which gives us, yes, you, Jack, 2. Then I'm going to take k, and I'm looking at it, Taylor, and I'm going to have k to the 6 minus what? What's my 1? Then Isaiah, yes, I'm going to take j to the, what's my power in the numerator? 2, right? My exponent in the denominator, what's that? To the 5th, so minus 5 as I'm looking at it. So I know my answer is going to have 2. Hadicia, 6 minus 1 gives us k to the 5th. J as I'm looking at it, Connor, to the 2 minus 5. Negative 3. Oh, can't have negatives, right? So as I look at this problem, I want to simplify it. Kaden, here's my fraction bar. What should be moving as I take a look at that? Yeah. Everything else stays the same, so tell me what to write. Yep. J to the 3, and that's in our denominator, right? Right? All right, so we look at this next one, and we have 18 over 14. Alyssa, as I'm looking at 18 over 14, you know anything that goes into both 18 and 14? What number? 2. I'm going to divide them both by 2. 2 goes into 18, Alyssa, how many times? 9 times. 2 goes into 14, Alyssa? 7 times. So right now, I still have this fraction. I have 9 and I have 7. Can we simplify that any other way? Is there any number goes into both those? No. So Stephen, you're going to start us with the a powers. A to the negative 3 minus what? 5. Next case, I'm going to have b to the what?
B to the 7th power minus b to the 2nd
Okay.
power.
So at this point, I'm simplifying this. I still have 9 and 7. I have a to what power as I'm adding those, Michael? Negative 8. Now, here's the biggest mistake. I'll have people put 9 to the negative 8. They just forget to write the variable. So a, make sure you put the variable. And then Parker, if I'm looking at b and I'm taking 7 minus 2, I should get 7 minus 2 that we are looking at for our exponents, 5. I can't leave it like this, right? This answer isn't simplified. Addie, if I'm going to simplify it, which one has to move? The what? Little louder? The A has to move, exactly. So if I'm writing this, I'm going to have 9. I'm going to have the 7. And then what, Addie? Want to do the top or the bottom? Okay? A to the 8th on the bottom. And in the numerator, we're still keeping b to the 5th. So you're going to have some problems like this on the test where I ask you, did they do it correctly? So you're kind of having to apply all these rules. So if not, how could we correct it? So the first thing I notice that x to the 4 over x to the 4. That is going to be x to the 0, right? Everyone agree? And anything to the 0, we wouldn't have to write it. So far, that looks good because there's no x here. I have y to the -1 minus, ooh, this is so tricky, minus -5. Put it like that. Put -1 minus and then a -5. And this is where your integer from last year, when you did integer operation, is going to come into help. And then we have d to the 8 minus 1. So if I'm looking at this, a -1 minus a negative becomes plus a positive. So if we are looking at that, that is y to the 4th, and 8 minus 1 is b to the 7th. So as we take a look at what this one, did they do it correctly? Yes. Everything was correct, but it kind of, because there was no x, sometimes I have people thinking they didn't do it right, and then this gives people major problems because they think it should be -4. They think -1 minus 5 or -6. So you just got to be really careful with those negatives, okay? Then we are going to take everything inside to that power. And some of you have been doing a great job on these very early on. You had x to the 5th and y to the 5th. You rewrote it as x to the 5th over y to the 5th. Here we have 3 to the 3rd, 3/5 cubed. You put 3 to the 3rd, 5 to the 3rd. This would be my answer as a power. So as we take a look at this one, we're going to do the same thing. We're going to start off and we're going to go 4 to the 2nd. Oh, but when we take power to a power, Jack Grunsvold, what do we know we have to do? With the exponents, the 3 and the 2 from yesterday. Multiply those. So I'm going to have p to the 6th. So my final answer, 16 over p to the 6th. This is my answer as a power, right? So if I say leave your answer as a power, you could leave it like this. But usually those simple squares, we should be looking at doing those. First hint is get rid of your negative exponents. How did they do that? They did reciprocal. What is it going to look like when we take the reciprocal? I'm going to have y to the 4th over 2x to the 6th, all raised to the 3rd. Now, I'm going to raise each of these to a power. What does that mean? That means I'm taking y to the 4th, and I'm taking that 4 times 3. It's hard to read in that space. I'm going to write it over here to the side so you can see it a little better. Y to the 4th times 3. In the denominator, I have to take 2 to the 3rd, not 6, right? And 8 to the 6th times 3. So this was my y to the 4 times 3. I'm going to multiply. And I think it's really helpful to just show that you are multiplying here. 3rd power, 6 times 3. So that when I look at that solution, I should have had y to the 12th, positive exponent, 2 to the 3rd, not 6, but 2 times 2, which is 4, times another 2, which gives me 8. And then I'm going to have x to the 18. Not by 5, but by, or not by 2, but by 5 goes into both. Okay, so I have 1 over 2. Then as I am looking at that, Kian, what am I doing with those exponents? Y to the 3 minus 10. I get y as I am looking at that, Addie, of what? Oh, -7. That makes sense. So it's going to be -3 minus 10, -7. And I have 2. Can I write the 1 there? Yes. Do I have to write the 1? No. Right? So I'm going to keep going with this one. And Jack Ellenson, I'm going to do what for my final answer? Which one has to move? Only the y. So if I'm moving only the y, you want to tell me what to write down for my answer? Oh, wait. Should I move the 2? No. So let's keep the 1. 2, and then, does that make sense? Okay. So we're not moving the 2. The 1 stays, the 2 stays, as we are looking at that one. All right. So there's two ways of doing this problem. I'm going to show you the first way. The first way is we subtract. If I'm subtracting those, Abby, I'm going to have k to the what? 1 minus 2. All of that's to the third power. If I get that answer as I'm looking at it, Stephen, 1 minus 2 gives me k to the negative 1, and that's raised to the third. So at this point, I have k to the negative 3. I can't keep that answer, right, Caden? I have a negative exponent. What am I going to do? 1 over k to the third. Oh, I don't like to do it that way. I want to take each of these to a power. I want to do this, k to the third. So this is the other way of solving it. Both ways work. Both ways give you the same answer. K to the third, because that's a 1. 1 times 3. 2 times 3 gives me k to the 6th. If I am subtracting 3 minus 6, don't I still get k to the negative 3? And then my answer is still 1 over k. So does it matter which way you do it? No. Sometimes it's way easier to get it down to one thing inside. Do that especially next year in algebra when you're looking at these kind of stuff, because they get even uglier. First thing, we have a negative exponent. Case and I can't have negative. We're going to do the what of m over n? The reciprocal. I do the reciprocal, and I have it now to the third power. And then in that parenthesis, I now have what?
N over n.
That's still to the third power. That means I'm going to have n to the third and m to the third. Okay? Michael, we're taking a look at this next one. We want to get rid of that negative exponent first. So tell me reciprocal.
5y over 4 and 3x.
Yeah. All of this now is to the fourth power. That means, as I start this, Connor, I have to take 5 to the what power? What number is out? So I have this is 5 to the 1, right? Let's just be real clear. This is 5 to the 1. This is 3 to the 1. What are you doing with these two numbers? Power to a power, we're multiplying. So we're really taking 1 times 4. A lot of you could just write that as 5 to the 4th, right? Hadicia, next we got to do our y's. We're going to multiply. Y to the 4 times 4. What's that going to end up with? Y to the what? Y 16. So I have 5 to the 4th. I have y to the 16. In the denominator, as I am looking at it, Jeannie, I'm going to have 3 to what power? 3 to the 4th. Zach, I'm going to have x to what power? X to the 8th, because we are multiplying the 2 and 4. At this point, this on the test, I would be happy if you left it like this, because I could see that you understood it was 5 to the 4th and not 5 and 3 to the 4th. Could you put those two in your calculator to get your final solution? Yes. So if I was looking at the answer when people put them in, 5 to the 4th actually comes out to be 625. 3 to the 4th is 81. But again, if I was looking at your assignment and you got to this point, I am fired up. That's where I need you to stop, okay, as you are taking a look at that.